All right, today we're going to be talking about a special type of probability, conditional probability. Now we've done some probabilities, some simple probability and compound probability, but now we're going to find probabilities of other types of events and talk about some contingency tables in order to use these. Now, here's the formula that they have for conditional probability. If we're paying attention, we really don't need all of this. It's actually more work than what we need to do. Let me show you what I mean. Kim draws a card from a standard 52 card deck. What's the probability that she draws a heart given that the card is from a red suit? Now, the problem with the conditional probability is this bottom line, given that the card is from a red suit. So we are really not going to have that 52 card deck part in here. We're really only going to take just the red suits. And how many red cards are there? Well, there's 26 of them in the deck. So that actually is going to be what my denominator is. What's the probability that she draws a heart? Well, how many hearts are there? There's 13. So it's just 13 out of 26, or just 1/2. And that's what it means to have conditional probability. It's the probability given a specific condition. It's not out of the 52. Now, the previous formula, if we go back, it uses the 52 in there, but it ends up being the top 13 out of 52, and the bottom ends up being the 26 out of 52, and the two 52s cancel out, and it's just extra work, and we still get the same answer here. So as long as we're paying attention and see that they say given, the given part is going to be my denominator, and the probability that will be the top part here, whatever they ask us for. So it is just 1/2. So let's try another one. Tally draws a card from a standard 52 card deck. And again, we're not going to use that 52 is kind of just extra information. What's the probability that she draws a jack, given that the card she drew is a face card? So there's 4 jacks, so that's my numerator, draws a jack. Given that it's a face card, well, how many face cards there are? There's 3 per suit, a jack, queen, and king, 4 suits for a total of 12. That's my denominator, not the 52, it's the 12. So it's 4 out of 12 equals 1/3. Now this is a contingency table. It goes ahead and breaks up multiple different questions. Here we have the number of students at a high school, the number of boys and the girls, so it splits up boys and girls, and then are they going to college or not? So it gives us a bunch of different conditions, and we can use that to go ahead and answer this kind of a probability. Find the probability that a student plans to attend college after high school if that student is a girl. So that student is a girl, that's the denominator. So we have to find out how many total girls there are. To find out the total girls, we're just going to add these two together for 514. And then the probability will be how many are yes. Again, just out of the girls. They're not asking anything about the boys right now. So it's 376 out of 514. 0.73. Now, here's a fraction. That fraction can be reduced a little bit, but not very far. That's not going to help us much. We don't like to leave our answers in decimals, so most of our answers off of these contingency tables, because they're real world examples, we're going to leave as percentages. So most of the conditional probability we will want to leave as percent. So we're going to leave it as 73%. It's just easier, and people understand that a lot better. If I told you this fraction, well, yes, it's 73%, most people aren't going to look at me kind of strange that I have that kind of a fraction, meaning 73. When you say 73%, people know exactly where that number roughly is. Here's another one, doing the same thing, but now let's talk about if the student is a boy. So we have to total up the boys. That's my denominator. And then does not plan to go to school, so 151 out of the 493, giving us 30.6 or 30.6%. Table shows the number of students who are varsity athletes. Find the probability that that student is non-varsity given that he or she's a senior. So let's figure out how many are here. Find the probability that the student is a non-varsity. So here's these numbers. We got to find out how many seniors we have. We have 308. Now, how many of them are non-varsity? Just the 257. Divide it, and you get 83.4%. And that's what I have for you today.